If the outlets in your home are not grounded, firstly consider using ground fault circuit interrupters or GFCIs. Install GFCIs on all outlets that are not grounded. GFCIs protect people from electrical shocks by tripping off the circuit when they detect a fault. Secondly, consider using grounding adapters. Plug grounding adapters into non-grounded outlets and connect the adapter's grounding wire to a metal water pipe or plumbing fixture. This will provide a partial ground and improve safety. When it comes to a ceiling fan without a wall switch, firstly, install a wall switch. Have an electrician install a wall switch for the ceiling fan. This will allow control of the fan and light from the wall, eliminating the need to use a pull chain. Secondly, consider using a remote control. Purchase a ceiling fan remote control that works with your fan. This will allow control of the fan and light remotely without having to install a new switch. Regarding wiring, firstly, consider partial grounding. Wiring the house with a 3-wire grounding system, typically a green or yellow wire, is ideal, but it can be expensive. As an alternative, consider partial grounding, which involves running a grounding wire from the electrical panel to the outlets in specific areas, such as a living room or office. Keep in mind that if there is any discomfort making electrical modifications, it is advisable to consult with a licensed electrician. They can assess the home's electrical system and recommend the best solution based on safety needs and budget. GFCIs are a crucial safety device, especially in older homes lacking proper grounding. A GFCI outlet constantly monitors the current flowing into and out of a circuit. If it detects an imbalance, meaning some current is leaking, even a tiny amount like 5 amps, it immediately trips the circuit, cutting off power and preventing electrical shock. GFCIs are particularly important in areas where water is present, such as bathrooms, kitchens, and outdoors. They are designed to react very quickly, typically within 3 seconds, which is fast enough to prevent serious injury. When installing GFCIs, it's important to follow the manufacturer's instructions carefully. They usually have a test button and a reset button. The test button should be used regularly to ensure the GFCI is functioning correctly. If the GFCI trips frequently, it could indicate a problem with the circuit or an appliance plugged into it. It's important to investigate the cause of the tripping and address any issues. Grounding adapters, also known as 3-prong to 2-prong adapters, provide a limited form of grounding for appliances plugged into ungrounded outlets. These adapters have a grounding wire or tap that needs to be connected to a grounded source, such as a metal water pipe or a properly grounded screw on an outlet box. The grounding adapter creates a path for stray current to flow back to the electrical panel, reducing the risk of electrical shock. However, it's important to understand that grounding adapters are not a substitute for proper grounding. They only provide a partial ground, and their effectiveness depends on the quality of the grounding connection. If the grounding connection is poor or non-existent, the adapter will not provide any protection. When using grounding adapters, it's crucial to ensure that the grounding wire or tap is securely connected to a known ground source. If there's any doubt about the grounding, it's best to consult with an electrician to determine the best course of action. Partial grounding is a compromise between a full rewire and relying solely on GFCIs and grounding adapters. It involves running a grounding wire from the electrical panel to specific outlets or areas of the home, such as the living room or office where sensitive electronic equipment is used. Partial grounding can provide a significant improvement in safety and reduce the risk of electrical damage to equipment. When implementing partial grounding, it's essential to follow all applicable electrical codes and safety standards. The grounding wire must be properly sized for the circuit it's serving, and it must be securely connected to the electrical panel and the outlets. It's also important to ensure that the grounding wire is protected from physical damage. Consulting with a qualified electrician is highly recommended when considering partial grounding. They can assess the existing electrical system, determine the appropriate GROUNDING Chinese letter ligature, and ensure that the work is done safely and correctly. Regarding ceiling fans without a wall switch, there are several options for adding control. Installing a wall switch is the most common and convenient solution. An electrician can run wiring from the ceiling fan to a new switch location on the wall. This allows you to control the fan and light with a simple flip of a switch. When installing a wall switch for ceiling fan, it's important to use a switch that is rated for the fan's motor load. Ceiling fan motors can draw a significant amount of current, so a standard light switch may not be sufficient. A ceiling fan rated switch will be able to handle the higher current draw without overheating or failing. Another option for controlling a ceiling fan without a wall switch is to use a remote control. Ceiling fan remote controls typically consist of a receiver that is installed in the fan's housing and a remote control that allows you to adjust the fan speed and then turn the light on and off. Ceiling fan remote controls are relatively easy to install and they don't require any additional wiring. They are a convenient option for adding control to a ceiling fan without having to hire an electrician. When choosing a ceiling fan remote control, it's important to select one that is compatible with the fan. Some remote controls are designed to work with specific brands or models of ceiling fans. It's also important to consider the range of the remote control and any additional features it may offer, such as dimming control for the light. Regardless of the chosen solution, prioritize electrical safety and consult with a qualified electrician for any work that involves wiring or electrical connections. Aluminum wiring, commonly found in homes built in the 1960s and 1970s, presents unique challenges and potential hazards. Aluminum expands and contracts more than copper when heated and cooled. This can lead to loose connections at outlets, switches, and light fixtures, which can cause overheating and fire. Aluminum wiring is also more susceptible to corrosion than copper. When aluminum corrodes, it forms a layer of aluminum oxide, which is an insulator. This can further increase resistance at connections and exacerbate the overheating problem. If the home has aluminum wiring, it's crucial to take steps to mitigate the risks. One option is to have an electrician install copper pigtails at all connections. This involves connecting a short length of copper wire to the aluminum wire using a special connector that is designed for joining dissimilar metals. The copper pigtail then connects to the outlet switch or light fixture. Another option is to replace all of the aluminum wiring with copper wiring. This is the most expensive option, but it provides the most comprehensive solution. It eliminates the risks associated with aluminum wiring altogether. In addition to addressing the aluminum wiring itself, it's important to ensure that all outlets, switches, and light fixtures are rated for use with aluminum wiring. These devices are designed to withstand the expansion and contraction of aluminum and to provide a secure connection. Regular inspections of the electrical system are also essential. An electrician can check for loose connections, corrosion, and other signs of problems. If any issues are found, they should be addressed promptly to prevent potential hazards. The National Electrical Code, or NEC, provides specific requirements for electrical installations, including grounding. The NEC is updated every 3 years, and it's important to follow the latest edition to ensure that electrical work is done safely and correctly. Article 250 of the NEC covers grounding and bonding. It specifies the requirements for grounding electrodes, grounding conductors, and equipment grounding. It also covers the requirements for bonding metal parts of the electrical system to ensure that they are at the same electrical potential. Article 314 of the NEC covers outlet boxes, device boxes, and conduit bodies. It specifies the requirements for the size, type, and installation of these boxes. It also covers the requirements for grounding and bonding the boxes. Article 406 of the NEC covers receptacles, cord connectors, and attachment plugs or plugs. It specifies the requirements for the type, rating, and installation of these devices. It also covers the requirements for grounding receptacles. When working on electrical systems, it's important to follow all applicable safety precautions. Always turn off the power to the circuit before working on any electrical components. Use insulated tools to prevent electrical shock. Wear safety glasses to protect the eyes from debris. If unsure about any aspect of the electrical work, consult with a qualified electrician. Specific NEC tables are often referenced in electrical work. For example, NEC Table 310.15b16 provides the ampacity of conductors based on their size, insulation type, and temperature rating. This table is used to determine the appropriate size of wire to use for a given circuit. NEC Table 250.122 provides the minimum size of equipment grounding conductors for various circuit ampacities. This table is used to determine the appropriate size of grounding wire to use for a given circuit. NEC Table 430.250 provides the full load current of alternating current (IC) single-phase motors. This table is used to determine the appropriate size of overcurrent protection for a motor circuit. Understanding and applying these NEC tables is essential for ensuring that electrical work is done safely and in accordance with code. When determining the appropriate size of conductors for a circuit, it's important to consider the load that the circuit will be serving. The load is the amount of current that the circuit will be carrying. The load can be calculated by adding up the wattage of all of the devices that will be plugged into the circuit and then dividing by the voltage of the circuit. For example, if the circuit will be serving a 1500 watt hairdryer, a 100 watt light bulb, and a 200 watt television, the total wattage would be 1800 watts. If the voltage of the circuit is 120 volts, the load would be 1800 watts divided by 120 volts, which equals 15 amps. Once the load has been determined, NEC Table 310.15b16 can be used to determine the appropriate size of wire to use for the circuit. For example, if the load is 15 amps and the wire will be insulated with type TW insulation, the table shows that a 14 American wire gauge, or AUG, copper wire is sufficient. When selecting overcurrent protection for a circuit, it's important to choose a device that will protect the circuit from overload and short circuit conditions. Overload is a condition where the circuit is carrying more current than it is designed to handle. Short circuit is a condition where there is a direct connection between two conductors, such as a hot wire and a neutral wire. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip or blow when the current exceeds a certain level. This interrupts the flow of current and prevents damage to the circuit and equipment. The appropriate size of overcurrent protection device depends on the size of the conductors in the circuit and the type of load that the circuit will be serving. NEC Table 240.4 provides the maximum overcurrent protection for various sizes of conductors. When installing electrical equipment, it's important to follow the manufacturer's instructions carefully. The manufacturer's instructions provide specific information about the installation, operation, and maintenance of the equipment. Following the manufacturer's instructions will help to ensure that the equipment is installed correctly and that it will operate safely and reliably. It's also important to keep the manufacturer's instructions in a safe place for future reference. Regular maintenance of the electrical system is essential for ensuring its safety and reliability. Maintenance tasks include checking for loose connections, inspecting for corrosion, and testing GFCI outlets. Loose connections can cause overheating and fire, so it's important to tighten any loose connections that are found. Corrosion can also cause overheating and fire, so it's important to clean any corrosion that is found. GFCI outlets should be tested regularly to ensure that they are functioning correctly. The test button on the GFCI outlet should be pressed to trip the circuit. If the GFCI outlet does not trip when the test button is pressed, it should be replaced. Electrical work can be dangerous, so it's important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on any electrical components. Use insulated tools to prevent electrical shock. Wear safety glasses to protect the eyes from debris. If unsure about any aspect of the electrical work, consult with a qualified electrician. Always verify there is no voltage with a properly rated meter before touching any wires. When working with electrical panels, be careful not to touch any exposed wires or components. Electrical panels contain high voltage, which can be lethal. If unsure about how to work with an electrical panel, consult with a qualified electrician. Never work on electrical equipment while standing in water or on a wet surface. Water is a good conductor of electricity and it can increase the risk of electrical shock. Avoid wearing metal jewelry when working on electrical equipment. Metal jewelry can conduct electricity and increase the risk of electrical shock. Do not use extension cords as a permanent solution for wiring. Extension cords are designed for temporary use only. Using extension cords as a permanent solution can overload the circuit and create a fire hazard. If additional outlets are needed, have an electrician install them. Don't overload outlets with too many devices. Overloading outlets can overheat the circuit and create a fire hazard. Use a power strip with surge protection to protect electronic equipment from power surges. Power surges can damage electronic equipment and cause data loss. Do not run electrical cords under rugs or carpets. This can trap heat and create a fire hazard. Replace any damaged or frayed electrical cords immediately. Damaged or frayed electrical cords can create a shock hazard and a fire hazard. Be aware of the location of overhead power lines. Contact with overhead power lines can be fatal. When working outdoors, keep a safe distance from overhead power lines. Call 811 before digging to avoid damaging underground utilities, including electrical lines. Damaging underground electrical lines can be dangerous and can disrupt electrical service. If a power line falls to the ground, stay away from it and call the power company immediately. Do not attempt to move or touch the power line. If someone is in contact with a live electrical wire, do not touch them. Use a non-conductive object, such as a wooden stick or a broom handle, to separate them from the wire. Call 911 immediately. Know the location of the main electrical disconnect switch in the home. This switch can be used to turn off all power to the home in an emergency. Label all circuit breakers in the electrical panel clearly. This will make it easier to identify the correct circuit breaker to turn off when working on electrical equipment. Keep the area around the electrical panel clear and accessible. This will allow easy access to the panel in an emergency. Have the electrical system inspected by a qualified electrician periodically. A qualified electrician can identify potential problems and recommend solutions to ensure the safety and reliability of the electrical system. These tables and articles are revised and updated frequently, and it is important to have the latest information for the location of residence.